Hi guys, my name is Nitish and my teammates are Ebenezer Daniel and Raja Prabhakaran. Our dataset is Goodreads book dataset. The goal of our project is to develop a book recommendation system that helps users discover books based on their interest and preference. The system utilizes simple recommended content-based filtering, collaborative filtering and hybrid approach to suggest books. We use total of two datasets, user rating and books features, in which user rating has books, user ID and rating, whereas books feature attributes like title, author, publisher, average rating, number of reviews and a language. The books has total of 1 million rows and the user rating has 300k reviews. We have done pre-processing like handling missing values, standardizing column names and data cleaning.
So now we are doing some pre-processing steps. So first we are handling some of the missing values. So here you can see the ISBNs are missing a lot, but we already have an ID. So we removed all those ISBN values, and you see some of the missing values in publishers and language. So we replace those missing values with their mode values, and there are a lot of description values that are missing. So we handle that by replacing those summaries with a TF-IDF matrix and substituting a summary that is almost similar to the different summary. So next we go to the users dataset and we found a lot of book titles in it, and we match those book titles with the book titles in the book dataset, and we found only a few of the book titles that were matched, and we found the unique values of those book titles, and it was only 51k. So we decided to take a subset of those book data and only keep the 51k as our unique book titles, and the matched users data set was 234k, and we kept that as our final users data set.
We are also doing exploratory data analysis on both users data frame and books data frame. The graphs for the user ratings are seen below, and also we see the top 10 most rated books. The first recommender system we are implementing a simple recommender system which uses a weighted rating formula. This was taken from the IMDb dataset, which is there in the reference notebook. So this uses rating and counts of review to give the top 10 recommended books. So the first output we can see here is for the 51k book data set, which is a unique data set, and the next output you could see here is for the 1.1 million rows. And the next recommender systems we have implemented is content based recommender, which uses content like description, author, book title and book name. So here we have implemented 4 types of content based recommendation. The first one is books description, which uses the books descriptions, and it also uses TF-IDF, which is commonly used for all the other recommendation systems too. The next one is book features, which just uses the page count, rating, review count and publication year. And the next one is metadata based recommender system, which uses the book's title, author and publisher. And the next one is hybrid metadata recommender, which is similar to metadata recommended, but which uses LSA and word2vec. So LSA is latent semantic analysis. Below here we could see the output for the content based recommender system, which uses description. So here you could see the tale of Squirrel Nutkin, which is not similar to Harry Potter, and since Potter is there in the description, it brings it out for us, and here is the result in detail for content based. And the next output we could see here is metadata recommender system, which kind of gives us this similar recommendations to Harry Potter, but it also brings up different Harry Potter books in different languages too. And the results for metadata recommender in detail is given below. And the third one, which is our best model, is hybrid metadata recommender, which gives us Harry Potter books and also gives us a different Harry Potter book which is not written by J.K. Rowling, which is based on it. And the last one is feature based recommender system, In this we are just using pages number, publisher rating and counts of reviews. So here you could see it doesn't really give you recommendations about Harry Potter. It just gives you the books which has the similar page number or the review or the publisher.
So now we are doing collaborative filtering. Collaborative filtering, we are just taking the users and finding the similar users based on their behaviors. So first we group them and find the user item matrix and the user matrix, and then we use the SVD method, and then we use the user based KNN. Here we have used the metric cosine. I tried to use Pearson, but it was not working. It had a memory error. And then we are trying item based KNN, and then we are trying non-negative matrix factorization. Based on all those 4 methods predictions, we are calculating the RMSE values, and based on these RMSE values we can see that the KNN item base was the least values, and it was one of the most accurate values based on this. And then we are getting the recommendations of these selected users for all the 4 models. So here you can see for this model I just checked the Excel sheet, and he has read Harry Potter 1, so it has given books similar to that, like 2, 4 and 7. So it is somewhat correct. And then we have compared it with the Checkaird similarity and cosine similarity. So most of these are more than 0, so they are somewhat similar. So from this visualization we can see that the KNN item based was the best fit models by comparing the RMSE values across the 4 models. So next we are doing hybrid model. So here we are combining both the collaborative filtering and the content based filtering. The content based filtering best fit was metadata recommender, but when we fit it into our hybrid model we faced a lot of issues. So we selected the second best model, which was the metadata recommender. So here we chose the KNN item based from the collaborative filtering and the metadata recommender from the content based filtering in the hybrid model. And also we have used alpha beta values to see how much influence the collaborative filtering and the content based filtering has. So we have used different alpha values and different beta values and found recommendations for each of those, and here are the top 10 recommendations, and these recommendations are much better than the previous recommendations. So the hybrid model is much better performing than the content based and collaborative model.
Overall conclusion, we implemented 4 types of recommender systems: simple recommender, collaborative filtering, content based filtering and hybrid model. And out of all these 4, hybrid emerged as the best one, as it was leveraging the strengths of both collaborative and content based, and each recommender system had its own drawbacks, and hybrid was able to overcome few of that. So from this project we believe the hybrid model is the best model among these 4 models. Thank you.